的这些 intelligence。然后 agentic engineering 就是说最近整个把它释放出来以后呢，他讲说就有点像把那个天花板再把它冲到可以10倍到100倍，因为现在等于是这个大脑现在等于是可以有长出手跟脚出来，在原来的这个过去几十年的这个 digital world 的这个 digital asset 呢，那透过 computer use， 透过 tool use， 这个时候长出来了以后，然后呢又好像这个 agent 的军团呐。
对，
那这个整个起来的话，那个威力是几10倍、几百倍，所以我很高兴的是说，很兴奋，就是说第4次工业革命来了，
在这个时候，
对，
关键的时候，
然后 agentic 再来了以后，
是
大家知道，其实过去真的是，即使在 assistant 这个阶段的时候啊，还是非常的这个 thin client，
对，
大部分是利用 cloud， 这一次 agentic 这个才真正的让这个 PC 扮演，就是还要再做这个整个这个多步骤的规划啦。还要就像 PDCA 一样啊，然后还要去怎么说 harness， 不要让这个，因为 AI 当然很厉害，但是有时候会有一些 hallucination，
对，
所以 security 什么这些东西，所以我想这些东西的话呢，让这个 PC 现在扮演的角色，我觉得 AI PC 终于找到最厉害的定位，就是所谓的 heavy client，
是，
所以我想是。
您讲到一个很关键的那个 security。因为如果说我不能够 trust 这个是 reliable 的 agentic AI， 我不敢用，不管你多 intelligent，
完全正确。
所以与其说我们讲绝对很重要 ，we want to make a very intelligent agentic AI machine，but most important we want to make a trust machine。
Yes.
这个 machine we trust, we will use it. No matter how intelligent， 如果说我不 trust， 它可能会出错，我也不敢用。所以我想这个大概是未来在 edge 端，不管是 PC 跟人的地方。我们要 intelligent 在一个 secure， 我们才能在 local 用。
就在 agentic AI 里面非常重要的一个部分，
非常重要，
要有这个 guardrail。
对
，OK，
对，太好了。那是
那我们再往下问因为你现在从 agentic AI 再下一个就是 physical AI 了嘛，所以你看我们看到，尤其从浩这边，你达明在短短几年就做到这么大的这个协作机器人的一个品牌可是这样机器人要变聪明，不只是靠一个 AI 的 model。还需要靠很多的 real data 去 train 这件事情。那我想从你的角度来看，说你有这么多的机器人在现在的工厂在做这些协作机器人，你收集到的这么多的 data， 那要怎么样才可以把它变成是再下一步，让更多的垂直应用可以来使用这样的机器人呢？或者是说我们在未来1-2年会看到怎么样的不同面貌的机器人呢？
谢谢布鲁斯。我先澄清一下，我们达明算是一个新创啊，比起 MediaTek S50 我们还是小，我们还在努力当中。对，那其实刚才提到很多都是 digital AI， 那 digital AI 其实在很多就是从 perception 啊到生成式啊到 agentic， 其实很多都还在 digital space。但是到 physical AI 的时候，其实它很大的差异。说 digital 你可以在你的 PC 在 server 里面做 training， 做 validation。但是 physical， 因为你有 simulation 这些，可是到 sim to real 有一些 gap， 所以最终你还是可能要在 real 的环境里面去 implementation。对，那这时候就会说，就比较就障碍会比较高一点。可是其实我自己是学control的我以前都学的是 kinematics， 学的是 dynamics。简单说啦 ，kinematics 其实就是数学 ，dynamics 其实就 physics。所以我以前学的这个东西，好像在新的 AI 出来之后，我们讲 physical AI 出来之后，好像这个好像我以前学的东西没有用。不过我老师说我自己的老师是说，你懂就是还是要教以前的原来的 model base， 就是刚才董事长这边提到的 model base。所以你懂这个最基本的 physics， 然后再去了解你跟sim to real 就 digital twin 里面到底有什么 gap。所以这个 gap， 所以我们 initiate， 我套一下我们总裁 Barry 讲的话，是 NVIDIA initiate 这样的机会。然后2年前我们都不相信说这个 robot 可以靠 training， 而不是靠数学跟 physics 来达成。所以它确实initiate这样的机会。那我们收集这些资料之后，如果可以生成，可以在digital twin 里面，在 virtual world 里面去生成，然后让这个 gap， 我说 sim to real 的 gap 越缩越小，这时候你去直接 deploy 就会比较简单。那所以这个就是 physical AI 它最大的 gap 应该在这里，但是 现在整个技术的这个migration 其实真的是蛮快的，我们也非常 excited 说我们在这个时代，不过确实也蛮 tough 的。
所以，那这个地方你觉得我们台湾在这个地方比较大的优势是什么？或者说我们怎么样利用我们有从最上游的晶片，我们在晶片端可以做在这个晶片上在算力方面能够提供到最好？台湾的优势在哪里？我们怎么样做这个上下游的整合，让台湾在这个physical AI 里面能够开创一个更大的一个空间呢？
好，谢谢布斯。我想我从2个层次讲，第一个就是台湾提供非常好的 infrastructure， 像台积电、MediaTek、ASUS， 包含广达，我母公司广达，所以整个 infrastructure 其实是建得非常的好。那也谢谢 NVIDIA leverage 台湾这样的一个 supply chain。那这是一块 infrastructure。其实 physical AI 我们也是 based on 的 infrastructure 做 training， 做data 的 generation。所以我们在这上面因为我们原来就有自己的工厂场域，所以我们很清楚这个应用在哪里。但也许没法一次到位，说像人一样做这么多事情，可是我们可以 define 很多事情。所以大家在讲这个世界模型可不可以马上一次到位？其实也许它无法一次到位，可是它在过程当中，我们可是有些事情也是可以做了，这个是我们蛮期待的，对。
我是真的非常期待，因为 Agentic AI 它已经进展到它可以推论，然后可以产生行动。那么想象这个 Agentic AI 从数字的世界到这个实体的世界，那如果透过 World Model 它能够了解物理的一个特性，知道说重力的速度啊，知道怎么样的情况之后，再加上推理，其实在一个 virtual 的环境里面，它去训练它的时候，它就可以去推论出来说可能发生的结果，什么是最好的结果。那这个商机是无限的，这个商机是无限的，就是在过去我们的不管是 industrial 或是 commercial 的这种 IoT 也好，它苦于需要历史的数据来做训练。但是有了这个推理能力，再加一个 World Model，World Model 在这个 domain 的 model， 比如说是在 manufacturer 还是在医疗，他知道他怎么运行，他的这个 domain 的 data， 这个 operation 的 logic 之后，他就可以去推论之后找出最好的决策，他就可以产生行动。所以您觉得这个未来的商机这么的大跟无限，台湾在什么地方可以是最好的机会去切入？
我刚才也提到，就是说台湾其实在 infrastructure 上其实算是提供给全世界这样的 environment 嘛，也提供所有的 solution 给全世界。那我们在 robot 这边，我觉得台湾其实因为台湾不管 chip 到马达到 gearbox 到一些 integration， 台湾的其实这个技术是蛮强的。那除了提供 component 以外，但其实台湾也可以，像我们达明机器人是算是一个 solution provider， 我们提供一个 robot。所以，如果既然有那么好的这种 supply chain， 其实除了提供给全世界以外，但其实如果我也乐见有多几家的像这种solution 的 provider 一起出来，因为另外台湾有一个非常好的场域，因为台湾各种的从 semiconductor 到不管是组装啊，其实这个都台湾是有非常好的场域。
所以我觉得这个 Rick 可能要帮我们讲一下，就是说从原本的这个 AI 这个需求，我们到现在的 Agentic AI， 甚至 Physical AI， 对于整个 chip 的这个 requirement 到底会有什么样一个结构性的改变，或者说在这个地方我们要注意什么东西？我们要这个哪些东西可以让联发科或让台湾这边可以更往加速的往这个 Physical AI 这边来推进呢？
其实我学到的系统，我想台湾很强的都是很多从我们是 bottom up， 很多 components、IP、IC、PC 等等等等，但在系统面，系统包括软体跟硬体。软体讲老实话了，是美国和大陆 dominate so far。硬体在系统面，我觉得我们台湾还需要更加的努力，因为我现在学到的是，你不了解系统，我们做的 IP， 我们做的 IC 常常会有一些 mismatch， 你后来花很多时间去解决、去改，时间上就来不及。所以我是 drive 我们的同仁，就是说你一定要了解 software 的 architecture， 我们在 hardware 的 architecture 跟系统一定要相连。这方面 我们一步一步都在学习，我们跟 NVIDIA 合作，让我们有很多很好的经验。但是到了最后，这个整个 IC 啊，它其实万变不离其宗了。其实基本上，你说机器人，我想我是班门弄斧啊。不过这个机器人当然有很大部分是 mechanical 的部分，你在 IC 的部分 ，sensing 当然很重要，然后就是 computing。computing 我是觉得啊，绝对做得出来的。只要我们跟台积电、跟 NVIDIA、跟大家、跟达明啊什么，大家跟数字大家合作啊，我是没有任何的疑虑，我们一定做得出来，做得很好。Sensing 这方面要看什么样，我想达明可能比我清楚一点，但整个系统一定要懂。整个系统不懂啊，我们就有点像瞎子摸象一样，从一块一块啊花很大的精神 ，time to market 我们就 lose time to market。这一点台湾很有弹性，可是又要快，又要准，又要好。这个我希望我们能够一起做到，大家一定要好好合作，对不对？一定要好好合作。
这个我感触非常深哈，就是说，其实刚讲到像这个机器人这边的话，其实现在美国跟中国啊都非常厉害，非常快哈。但是我觉得台湾必须要拥抱这个现实，所以还是要再多一些这种深耕型的这种哈，就是我们把它叫做从 paper 到 product， 那么真正把刚讲的这个整个 system 的 engineering 是或者 Jensen 在讲的 full stack， 那你知道整个所以然以后，因为现在有 AI 以后，整个是 integrated 的，所以要在这边能够做到收塔。你如果不这样去贯穿的话，事实上的话，你可能很难真正跟人家可以比拼。所以像我们在讲这个 agentic AI 这个部分的话，最近因为这个对整个 AI PC 终于找到一个很重要的定位以后，但是这里面的话一样，你怎么样去掌握？所以像 N1X 其实是做了非常好的 architect， 在整个到需要多大的算力，然后再必须考虑到像这个 notebook， 你的这个 power consumption。那么在真正发挥 agentic 的时候，我想大家知道一个很重要的东西，就是说你最后到底要用 local 的 model， 还是要用 cloud 的 model？ 这个整个 hybrid model 里面，那最近这几年其实整个这个不是只有在 cloud 这边的整个这个 model 的这个进化其实尤其是 open source 那这个我知道大家知道中国都非常强所以这边很多的这个 state of the art 的这些东西，然后怎么样反而在这个 agentic 的时候，因为是变成在 local 就要能够推理，为什么要这样呢？大家知道现在最近 agentic 开始以后现在这个 token 开始要付很多钱所以现在成本的问题变得很严重。那本来 local 就有很多重要的东西，像你的这个 low latency，像你的这个整个这个 security 更加的 personal， 这些东西都是它的优点。所以这些东西加在一起的时候，这个 local 的 model， 事实上因为过去在 open source 这边整个进化真的非常快。那大家知道在 local 的时候，其实你不一定要像在 cloud 那样的 model 是等于百科全书全知型的，所以在 MOE 的观念就变得很重要事实上你着重在更加深入跟这个有关的东西，然后更重要的是你在这个 local 里面的话，怎么发挥 local 的这些所以在整个这个我们一般在整个算力还有这个 memory 的这个 bandwidth， 还有这个 memory 的 footprint。这里面的话呢非常重要，这里面如果能够做得很彻底，所以我才讲说 from paper to product， 你如果没有把它搞得很彻底的话，你结果呢可能是 memory bound， 结果你太多的这个 TOPS 浪费掉了所以我想这些的话呢都是必须要真正深耕，然后呢要去做出最佳的这个 balance。 Hybrid AI 的话，你两边到真正最厉害的时候，你还是可以利用 cloud。
对。
所以我想这里面两边的这个更加需要很强的这个 system 的这个 engineering，hardware 跟 software full stack， 那才能够真正把它发挥到淋漓尽致。这个是我们很兴奋的地方。
所以换句话讲，做一个 PC OEM， 它要做的不仅仅是一个平台，它必须要贯穿上一层的应用。Purpose build 给什么人用？他是 gamer 还是 creator？它来做什么用？把它上面那一层的需求，然后把它整合在一起，这样 user 他拿来用的时候是有意义的，去 support 它。 这个是我想您刚刚所提到的那个贯穿，不能只做 paper， 要把那个贯穿的一部分把它做出来，才能够真正落地。
对，所以我想台湾过去当然很 proud 我们的这个 supply chain 啊，这个，但是我一直就是很有感慨，就是从 Intel 时代开始，其实真正这个吃香喝辣的是这个Intel 跟 Microsoft 嘛，那华硕是比较愿意，就是说从 paper 到这个 product 也是下了蛮多的功夫了，希望有一些 differentiation。那在现在这个时代的话，你刚刚讲了，所以其实不能够只是满足于，就是最前沿的那个 design 里面很重要一个东西叫 design thinking。你如果没有在 design thinking 这边真正跟这个 desirability， 你等于最源头的东西没有的话，那常常可能是牛头不对马嘴，或者说完全就是听人家讲的东西。所以这个能力在台湾是特别的缺的。所以我觉得台湾为什么我一直讲说，我在台大那时候也一直在讲说要深耕型，包含台大最近在很多的 paper， 我想你看现在最近大陆实在是太强了，所以这个是我们要很谦虚，就是该拥抱现实的要拥抱现实，然后赶快把这些东西补起来。台湾还是有很多现成的这些有利的点，那这样的话才有办法去对付这样的一个问题。是，
所以总结来讲，我们今天听到这个在座的3位来宾，有一件很重要的事情，就是说台湾的优势是我们的基础的建设系统，但是同时我们要这个垂直的领域去深耕、去突破。我们有不足的地方，不管是应用场景，还是解决方案，还是跟第三方的合作，在开放平台，我们都必须要更宽阔的这种方式去拥抱、去挑战。因为这个在未来的机会是无限，尤其是在这个 physical AI， 怎么样去把握，这是一个非常重要的部分。非常谢谢各位3位来宾的分享，今天谢谢。
AI 是人类有史以来最强大的工具之一。它让我们学得更快，创造得更多，能解决更困难的问题，更能把梦想变成现实。而 AI 已经开始真正的动起来，它会推理，会使用工具，甚至能跟真实世界互动，能够自己规划、整合跟随时调整的 AI agent 推动下，台湾的工厂、机器人、供应链变得更聪明，也更强大，而且永不停止脚步。
The age of AI agents is here. AI agents represent a significant economic opportunity. They will be integrated into every industry, changing how companies operate and how work gets done. The next frontier is physical AI, systems with a body that can perceive, reason, plan, and act in the physical world. Taiwan's manufacturers, automation leaders, and robotics companies are using agents and physical AI. This will usher in a new era of robotics, where intelligent machines become an integral part of every industry and everyday life.
台湾的制造业者已经把 AI 代理人实际用在工作上了，打造出智慧工厂、仓库、工业系统，还有机器人。接下来有3位实际把 AI 带进工厂的3位主讲人要加入我们。第一位 Casey 杨，鸿海科技集团 AI 软体负责人，也是集团史上首位女性 CEO。
大家好。
童子贤，我想大家都认识了，这个和硕联合科技集团董事长兼首席策略长。Simon 张，台达电子总裁兼营运长。那我们先从我们刚刚讨论很多这个机器人哈，那我想 Casey， 你站在这个产线、仓库跟全球供应链的第一线哦，我想你比所有人都清楚工厂到底现场长什么样子。那我听说鸿海最担心的不是 AI 太贵或太难，而是你们够不够快，能不能满足这个 AI 的这个需求。
对，
对于你们来讲，把 AI agent 放进每一座工厂、每一条生产线，到底最难的是什么？那这件事情做完了之后，这个制造会是现在的制造，还是整个制造会我们会有完全不同的定义了呢？
好，那个 Bruce， 我说实在的话哈，在我们去导入这个 AI 进行到智慧制造的时候，坦白说，我们的担心可能比导入之后还要高，反而是导入之后，我们都松了一口气。其实我们在2年前我们就已经呢开始在做这个智慧制造，而且我们导入一个专案名称叫 Genesis。 这个 Genesis 这个中文叫创世纪，所以我们对这个专案期望很高了哈，就希望它能够有这个不一样的这个制造的世界。那通常呢，这个有这样的期待之后呢，这个你看它这个 Gen 嘛哈，我们又把这个 Gen AI 呢当成它的一个这个导入的主轴。那我觉得呢，先跟大家讲我们的结论好了，3个数字给大家。第一个，我们现在排线的产能效能提升50%，哦，然后呢，我们的误判率下降50%，然后呢，我们的这个就是异常的真因分析提升精准率到90%，那大家就会很惊讶，我们怎么做到的？其实跟大家说哈，我们其实做对了3件事。第一件事情哦，很多人都会想，哇，我要导入 AI， 我一定要先赶快搞进很大的这个专案。其实不是，第一件事情一定要把资料收集好。所以我们呢，在第一件事情，这个是我们刘董事长非常有远见的地方哦。他要求我们做什么呢？先把会议记录都收集好。过去几年来，所有的会议记录都先收集起来，所有在异常问题所发生的任何的异常的过程处理的流程记录收集起来。我们发现这个事情我们做太对了。今天回头来看 ，data 是最重要的。第二个是什么呢？你不要期待 AI 马上帮你做天翻地覆的事，所以你要把它放对位置，你要让它真正的进入什么呢？你的 workflow 去。而且呢，第3个是什么？看到对的点、痛的点、合适的场景，你就赶快进入，你不要再等。所以刚刚就 Bruce 讲嘛，我们其实担心的不是怎么导入，我们担心的是不够快。所以呢，在这2年，我们用非常快的速度导入非常多的用力，而且这些用力现在都用得非常的成功。我举一个厂长的故事给大家听哦。厂长的这个工作是什么？他就是要保质保量，对不对？每天所有的产能他一定要交付完成。可是呢，讲得很简单，但是大家知道吗？他每天早上进来，他要开多少会议？有多少供应链、生管、品管、采购要开会，才能确保我们可以达成这个效益？但是现在不是，我们导入了一个叫 Agentic Ops AI。这个一导入进去之后，现在我不能说轻松啊，不然我们常常会这个就能够把所有的资料全部看完，让他做决策。所以我要讲哦 ，AI 并不是要取代人，而是 AI 要让人可以把时间花在更有意义、更有价值的地方。所以我想这个是我的回答。
哇，真是太棒了！我想这个 AI 的确不是要取代人，只是让你做更多事情而已，它可以管更大的工厂的，对不对？
是。
好，那么我接下来想请教这个董事长哦，这个 Agentic AI 已经从这个数位的世界进入到这个实体的这个物理的世界哦，那它可以进行推理，它可以产生行动。那您认为就是说，在未来的工厂的生产的过程当中，有哪一些环节会因为使用的 Agentic AI 来带来最大的一个利益？
我想那个过往的工厂呢，大家都知道，有大型的工厂其实是非常的复杂。你会感觉刚才所提的从生管物料到实体制造，有很多复杂的事情要解决。那我们先抛开过往，我们来有一个这个期待未来是怎么样我们有听坚神在描绘一个未来的世界当工厂呢，它采用的 Agentic AI，Agentic AI 跟 Physical AI 结合的时候呢，工厂不再是旧的非常辛苦、非常混乱的这一种状态。它会变成非常有秩序，错误非常少，效率非常高，决策非常有逻辑，有流程非常清楚。当意外发生的时候呢 ，Agentic 的 AI 呢有能力去帮你解决我们来举例来讲旧的工厂现在赋予它 Agentic AI 的这个软体环境之后呢，它有感测器它的感测器感测到某种状态的时候呢，它也会做出判断跟决策。这个时候，如果你的工厂里面还有一群 Physical AI 的那个人形机器人的话呢，它本来在从事替代人很辛苦搬运轮胎，拿那个很重的扳手在锁很重的螺丝当一群这个robot 走过去的时候呢，工厂的 Agentic AI 会跟他沟通说：“你们这几个 暂停一下，我发现工厂的某一个地方的变压器有一点过热。这个时候工厂的 Agentic AI 会协调 Robot 呢去巡视跟检查。那偶尔也有一台可能也可以派出一台无人机，这个无人机也具备 AI 能力，它其实也是一个这个 Robot 一种会飞行的 Robot。它可能可以飞到某一个角落去检查哪一个故障的零件，然后通知机器人去帮它修复。那像这样的情形以往听起来好像科幻场景、科幻小说，再过来不是了那我引用我们以前这个念佛的人会讲说，人可以跟这个世界沟通，是因为你有眼、耳、舌、鼻、身、意你的眼睛、你的耳朵你的舌头、你的鼻子呢，都是你的感官，跟物理的世界、实体的世界接触。可是那个意呢，那个意就是你的 LLM 可能就是你的 model 你有这个眼、耳、舌、鼻、身之后呢，透过这个意去跟实体世界沟通，那这样就摆脱过去3年来我们在用generative 的 AI 的时候呢，其实只有耳朵，它听得懂你的自然语言，它也有思考，也有脑袋，它也有嘴巴当它把它思考出来的结果用嘴巴告诉你，也是用自然语言，但是它缺少什么？它缺少手跟脚跟身体。好，现在 physical AI 补足了眼、耳、舌、鼻、身、意这一块未来的工厂，它的效率高它的运作有次序，它可以让人也减轻很多体力的劳动目前的定义是这样就是 robot 呢，它会大量的这个机器人，它会取代人类最繁重、最耗体力的工作所以一个理想的世界应该是生产力很高，大家又不要那么辛苦这是一个理想世界。
这里面大概讲的还有一个重点，就是说它是让我们人的技能也在转型，我们把我们的技能放在最重要的工作上，让我们的工作更有效率，生产力更高。
没有错。
那机器人它可以多工，OK， 它可以做这个也可以做那个，而不是这单一的事情，所以它非常的灵活。
我们在讲agentic AI 有些人都会直接把它联想到机器人其实机器人，也就是说所谓的这个被 embody 的一个 AI 呢，我们在讲无人自驾车，其实也是一个装上轮子的智慧机器人达文西一个这个开刀的这个手术的下一代的这个达文西呢，其实就是一个机器人Boston Dynamic 它有做那个4只脚的机械狗，当你要去救灾，当你要进入一个危险的这个工地的时候呢，你可以先派机械狗去，它其实也是一个狗型的一个 robot 也就是说，刚才举的例子，无人自驾的计程车跟机械狗跟达文西，他们其实就跟 robot 人形机器人一样，都是 physical AI。这个 physical AI 配合上像最近半年非常流行的龙虾那龙虾就是说它是一个软体，可是你会发现它可以替代你滑滑鼠、打键盘跟自动下单买股票你把刚才的这个 physical AI 跟龙虾这样的agentic AI 结合的话呢，未来人类的生产力会非常的高，不会停留在以往只能替你泡咖啡。
是，我想这个还是要回到一个最根本的问题就是说这个要支持这么多的 AI 的发展，我想电是一个非常重要的一个问题就是 Simon， 就是说现在看起来这个其中一个很大的挑战是怎么样把电一点都不浪费，又稳定的送到 GPU 的旁边，送到 XPU 的旁边那 Delta 在这边很特别一点，是从电网等级的电气设备一路到 chip 端的这个电源模组，从 Grid 到 GPU 也是另外一种形式的端到端就说这个在全世界很少公司可以做得到。那我想说你要怎么样利用这个优势，在整个 AI 能源时代的这个基础建设里面扮演更不一样的角色？
我想台达在做这个电源 的产品线的时候，我们就很早就开始规划从电网到 chip， 所以有很多现在看到的产品都不是今天端出来的，是已经默默的做了5年、10年啊。比如说像现在在谈800伏，我们这个早就已经开始，下一波要用固态变压器 SHT 取代传统的硒钢片的变压器，这个应该会在这1、2年，最慢明年就会爆发哈。这个时候，整个电源系统它变成是可调可控啊，在过去传统的 AC 是不可调不可控，那改成 SHT， 从中压、中高压一直变化下来，它是可调可控，它可以适应这个 AI data center， 它的 loading 是 up and down 非常的厉害，所以传统的电源系统它是要用很多的电容器、电池来做瞬间的 backup 啊，那它没有办法，传统变压器没有办法做调整，但是 SHT 可以。那经过这样子，就会让整个端到端的效率有效的提供，而且我们可以看从中压一直到0点几伏，这中间要变换很多次，每变换一次，它的loss就会增加很多。那如果导入 SST 以后，中间有很大一块的原来现在的产品会不见了，所以它转换的次数变少，效率又会大幅提升。那很多人在讲说，你这样子不是把自己的产品都杀掉吗？我觉得不可以这样考虑，因为这个是趋势。如果你不站在趋势的浪头 leading 这样子的 industrial change， 那你等别人做，你再花脑那你丢掉的不是既有产品，是未来的整盘棋，整个市场都不见了。所以台达在这个电源系统里面，我们真的是有很多单位在做啊。那除了这个电源之外，我们还有提供很多的这个散热啊，因为只要有 loss， 它就会有热。那唯有电源系统加上散热系统，你才可以发挥整体的效益。我想台达要做这么范围这么宽的产品，我们已经不跳脱传统的这种产品 design 的经验啊，我们把 AI 导入设计阶段，我们里面有一个大的 program 叫做 Smart Design 啊，那从 AI 用大模型的就开始 review 市场的 information， 然后客户的规格啊，然后 safety 的要求、法规的要求啊，都会让 AI 帮你做 summary， 要不然 engineer 要花很多的时间去读啊。那这个读规格不是他的专业领域啊。那接下来我们把所有的电子元件、电路啊，或者是整机都建成 digital 的模型、数位化模型。那在还没有做硬体之前，我们就在 virtual 的环境里面不断的迭代很多次，找到最佳设计，才开始去制作样品啊。那样品出来以后，你就很快的验证你的 simulation 跟你的硬体之间差异有多少。那最后的 testing 也都是可以在 virtual 里面环境完成。所以我们现在可以讲说，未来会用 AI 的公司才有机会，不会用 AI 的公司可能会退出市场，因为我们的预测啦，整个 design cycle 可以最少减少50% 啊，design cost 会少也是50% 以上，因为你所有的 try and error 都在 computer 里面，它是只要 token 付钱就好了，其他都不用付钱啊。然后出来以后，马上它的这个规格或者是生产条件，它也会产生出来，所以跟我们的 smart manufacturing link 在一起。所以让产品进入 产线的我们叫做 New Product Introduction， 就 NPI 的流程会大幅缩短啊，会让我们的产线很快的就接上来啊，那整体的效应会大幅的提高。所以在台达的整个企业活动里面，我们有几个大主题，一个就是 Smart Design、Smart Manufacture、Smart Quality 啊，然后试着把整个台达的制造业的完整的 process 都让 AI 来辅助，来帮助我们，让效率整个提高。
你看崔姐，你看台湾的这些制造业的真的很厉害，都已经把智慧的制造都已经融入。我想各个3家公司的工厂里面都有很多协作机器人。但是 Casey， 我想多问一下，你们好像已经把工厂的机器人往新的这个 vertical application 去做，比如说我听说你们在医疗方面也做了不少这个协作的机器人，你要不要跟我们多讲一点，怎么样从工厂你本来最擅长的工厂管理生产的机器人，往各种不同的应用来做呢？
好，我觉得我们在谈机器人的时候，先绝对不要忘记一个很重要的这个解决方案，就是 Omniverse。这个我要讲这个 Omniverse 真的是 amazing 哦。它在专门解决什么问题，大家知道吗？它在解决那个千金难买早知道。很有趣哦。那个其实因为在没有 AI 之前你的试作成本其实是非常高的。所以呢，我们如果有很多的异常工作，工程师他如果这个没有办法提早去知道问题、解决问题，但他常常会告诉自己，我如果早知道这么做，不就更好了吗？但是现在有 Omniverse 之后它不是只是个模拟工具，这个 Omniverse 它现在帮助我们在工厂这个所谓的硬体、软体、workflow， 包含整个环境。包含我们在做这个 AI 的这个 server rack， 我们就知道那个很热的那个需要热对流的模拟这个 Omniverse 全部都可以帮我们做。所以我们呢可以在虚拟的环境不断的做模拟，不断的做训练，不断的这个就是学习，然后不断的优化。当它达到一个最佳效益化的时候，我们再把它放到物理世界去。所以我们机器人也是一样，我们机器人呢。不是没有训练就把它丢到实体世界里面去，一定是把它先放在虚拟世界里面去做很多的训练。所以我们现在在用 Omniverse 我们在做这个新建厂跟产线的设计还有这个部署按照我们现在最新的这个规划还有实际的验证来说，我们现在大概时间缩短了60%以上，60%以上。这是个非常非常大的进步。我们现在的机器人在美国已经实际上面可以做到什么呢？它现在可以做到 pack， 然后它可以做到简单的组装、锁螺丝，这些都可以做可是各位，这个不是机器人我们认为最大的价值。我们认为机器人最大的价值是什么？是提供柔性制造。以前我们换一个产线，童总大家就知道，我们一个新机种一换。我们的这个设备大概都要换掉了，对不对？但是我们现在有了这个机器人，我们可以怎么样？把这个抓夹换掉，末端工具换掉，我们再把这个 software 再做一些 upgrade， 我们就可以开始使用。这是我们看到最大的一个柔性制造的帮助。那我们现在呢，不仅是在工厂应用这样的一个 solution， 我们现在也跟荣总合作，把我们机器人就像刚刚 Bruce 说的。导入到实体的这个医院里面去帮助护理师，因为护理师以前花了太多的时间在来回搬运走这个样品室药房拿文件现在都不需要，全部交给我们 New Robot 护理机器人就可以帮他解决这个问题。所以我们觉得呢，有了 AI， 有了机器人之后，我们认为他们最重要的一件事情就是什么？改变人类的生活，这是我们所看到的。
是，
谢谢，
谢谢。我想我在 follow 那个刚刚的问题的，童董事长就是您在这个实施这个 AI 在工厂制造导入的时候，你有没有碰到任何这种抗拒，来自员工的抗拒，然后怎么样去消除他们的抗拒，拥抱，然后愿意来使用这个 AI 做这个进行的？因为其实人是一个很重要的一个因素，成功与否。那这一部分您可以稍微分享吗？
目前，我们会解说的是说，这个世界会变得更好，你的工作效率会更高，你的产出会更高。 在同一个时间，你的这个不用流血流汗冒危险，或者付出很大的体力啊。那我们要回过头来这样讲。洗衣机的发明并没有取代家庭主妇的地位，
是，
微波炉的发明也没有取代太太的地位啊。好，我开玩笑说，洗衣机跟微波炉让太太有更多时间去管她老公这样子。
是，
员工也应该要抱着这样的心情，就是说，有了 AI 有了physical AI， 它帮你分摊掉很多，一个是体力上的粗活比如说现在的这个 robot， 它可以工厂里面担任吃重的工作，像龙虾这样子的这个 agentic 的 AI， 它可以取代什么呢？取代脑力上的粗活因为有些人的工作很无聊嘛，就是在网页上看，然后就在那边按键。未来这个东西都可以 agentic AI 来取代那相对的，人类社会的生产力更高的时候呢，你就可以发展更多、更有趣更丰富的这个职涯时光倒流200年，70%的人口都必须要在农田里面耕作现在透过化学肥料、透过耕耘机大家的农业的生产力解放了。50年前，衣服还是一个还蛮贵的东西，现在透过大量的工厂之后呢，衣服跟刚才讲的粮食温饱都让我们这个可以用很轻松的方式取得。未来在工厂里面的生产力，或者办公室里面的生产力，也可以透过 physical AI 跟 agentic AI， 让我们的工作更有趣，生产力更高。就像农夫不要太担心失业了，你整天绑在农田干什么呢？家庭主妇也不用担心自己没有地位，你整天绑在洗衣服、搓这个洗衣板干什么呢？未来的AI 无论是实体的 AI、physical AI， 或者是虚拟的 AI 都可以帮助你的生产力。所以员工放心，不会失业，你的工作会更有趣。
我只有一个要补充了，这个洗衣机的确是帮了我不少忙，不是帮我太太就是。
不过 Tracy， 我想 echo 一下，事实上，我们在导入这些智慧制造的时候，一开始我们其实很多厂长也是心里有很多担忧的，但是就是真的到现在，我们厂长是完全拥抱，完全拥抱。
我想
因为得到好处嘛。
对，其实这个是一个过程。那这个刚开始的抵触是来自于不了解，有些害怕。但是您开始了解，让员工知道说对他的帮助是什么，经历过之后，他就会开始使用。
是的，
过程是一个过程。
而且他们 enjoy，
那最好了，因为唯有人能够去拥抱、去使用，他才能够成功。
是的，
是。
对，我想这个机器人跟这个 Agentic AI 到 Physical AI， 就是说我们3年前来看这 GTC， 2年前、1年前，你可以看到很明显的改变。就是3年前我们在看的时候是 Generative AI， 到去年到今年，今年看起来这个 Physical AI 的曙光已经看到了。好，所以这个东西我觉得这是这3年很明显的改变。我们从一早上的主讲人到现在到你们真正实际在使用这些方面，我想这个 addressable market 看起来是非常非常惊人的对，
是。那么我们就稍微做一个总结吧。OK， 这个总结就是说，这个 AI 的未来呢，将会首先对不起。我们要谢谢3位来宾今天的分享，非常感谢各位，谢谢。AI 的未来取决于各项资源的取得，包含算力、云端基础建设、研究平台，以及那些能让企业与开发者真正动手的开发工具。这就是为什么台湾正全面投入 AI 生态系统的一个建设，从每一个环节全力支持下一代的创新。
AI development depends on the full stack coming together. Compute, platforms, talent, and local infrastructure. In Taiwan, that ecosystem is taking shape, connecting researchers, startups, and enterprises with the computing and platforms they need to build and deploy AI locally and for the world. Startups accelerating innovation, researchers advancing discovery, and enterprises scaling intelligence. The entire ecosystem is being enabled. This is driving a new wave of innovation. From AI factories to AI agents to physical AI built on a common architecture that spans from cloud to edge.
AI 正迅速成为每个国家都必须投入与支持的重点。能否取得算力，已经提升到国家战略资源的一个高度。台湾现在站在最前线，为台湾也为全世界建设 AI 基础，真是展现取得算力资源多么的重要。那么接下来3位来宾正是推向这一项工作的重要推手啊。首先，我们欢迎第一位是叶威严，通用机器智慧云端创办人兼执行长。第2位李宏毅，国立台湾大学教授。第3位姚延忠，亚湾超算创办人兼执行长，富士康的 AI 基础设施部门。那在正式开始提问之前哦，我想跟各位分享一个小故事哦。大概在这个10多年前的时候，我曾经有一个机会访问这个 Jason， 那时候我就问 Jason 说，Jason， 如果说您可以给一个台湾的新创公司，说未来想要做新创的一个公司，或者是说年轻的学子，他未来要步入这个 AI 的产业啊，您会有什么样的建议？那他当时给了我3个答案，10多年前我到现在的印象还非常深刻。那我觉得到现在还适用，所以跟各位分享。他说第一个是，你必须要对这件事情充满热忱，你要有兴趣，因为有兴趣你就会持续投入，不管多困难。那么第2点就是说，这件事情它必须带来有极高的一个意义跟价值，对于产业或者是对商业的一个影响，它必须是要极具的影响力，因为这个产出的价值才能够延续哦。那么第3个是说，你必须要挑这么多事情中哪一个是最困难的，门槛度最高的，因为只有门槛度最高的、最困难的，它的竞争优势才能够持续下去。OK， 所以我觉得到今天不管是在新创或是个人就职职业都是可适用的。所以我想第一个问题就先请问这个李教授就是你长期跟台湾的不管是新创公司或者是年轻人学子，他们要这个步入这个 AI 的部门，您觉得就是说，在未来的这种培养人才这个部分跟过去有什么不同？然后怎么样能够让这些人才能够在这个刚刚所说的例子里面找出一个真正挑战困难是最大，却又能够改变产业的一个方向？我想说，您是不是可以分享？
如果呢，你是在讲现在这个时间点，当然我们需要有能够开发 AI 的人才，有能够部署 AI 的人才，有能够应用 AI 的人才。那等一下其实也可以听一下2位业界先进，他们现在需要什么样的人才。但是如果我们把眼光放远一点的话，假设我们从5年后来看，我其实要问的问题是，我们到底还需不需要培养人才？尤其是我们所谓传统的 AI 人才。如果我们所谓传统的 AI 人才就是那一些，比如说能够训练模型的人，那未来这个训练模型是不是还是由人类来做？会不会可能其实是由 AI 来做？我们现在已经看到太多的蛛丝马迹是往这个方向走了。大家可能前几天才看到说 OpenAI 说，哇，他们的模型解决了什么很难的数学问题。今天你常常看到类似的新闻，就算在我们实验室也看到很多这样子的例子。比如说有一个同学呢，他有个博士生，他很厉害，他发现说呢，过去有一个大家常用的算法有一点问题，他就把这一个演算法呢直接丢给 AI 说，你是不是觉得这个有问题？ AI 就说确实有问题，给了我们一个新的证明，然后我们就发表了一篇很不错的文章，颠覆我们原来的想法。所以我会觉得，就未来而言，很有可能那些开发 AI 的也是另外一个 AI。未来很有可能你开发 AI 的方式就是告诉他说，帮我把这个东西 optimize 了，或者说我现在需要一个语音语言模型，帮我打造一个语音语言模型，然后他就像是一个工程师，也许就完成这个任务。所以我反而会觉得，假设往后看5年、10年，也许我们真正重要的是那一个知道要 optimize 什么的人，那一个知道我们的需求到底是什么的人，然后他知道说怎么去评量一个模型。当模型持续在 optimize 的时候，当我们模型持续在发展，它持续在训练的时候，持续监控它，确保它走的路是我们要的。比如说，我刚才说，假设有一个人要先说我要打造语音语言模型。 为什么我们要打造语音语言模型？为什么我们人类需要它？为什么它是一个我们现在需要的模型？需要有人去判断它的价值。然后在训练的过程中，我怎么知道它越来越好？要有人持续的去评测、去监控。我反而会觉得，这是在5年后可能最需要的人才。
所以您讲的一个重点，我理解是说，不是只是一个 AI 的一个技术的这个就是追求，而是在各行各业每一个领域，你都必须要深入了解，你才能知道说这个优化到什么程度是能够解决这个问题。所以各个领域的一个强项也是要同时培养，所以我不能只单靠我知道 AI 技术，而不知道各行各业某个深入的商业领域问题在哪里。这样的结合才能够让未来 AI 人才更具竞争力。
对，如果要讲一个 slogan 的话，我觉得说未来的世界啊，想做什么比会做什么重要。重点是你想要做什么，而不是你已经会做什么。
那想做什么就已经步入到他已经有一些思考，他有一些发想，他才能够做到那一步。所以这是一个非常好的一个建议，对于未来的 AI 人才怎么培养。谢谢。
我想到这个想做什么又有行动力又年轻的人才，我们就要把 Alex 叫出来了。对 Alex 啊，你花了半年时间在美国问土地、问变电站、问能源法规，硬是把怎么样办 data center 的这一套新法都带来台湾了。那你把这个昂贵又难取得的 GPU 算力，让台湾企业可以随选随用，就是基本上跟水电一样的 all you can eat。那你觉得这个台湾的新创企业，在取得算力上，他们目前最大的痛点是什么？那当算力可以被你这样很顺利的 provide 给他们的时候，整个台湾 AI 创新的速度又会有怎么样的改变呢？
我觉得这个问题非常好。我觉得过去可能企业在使用 AI 的时候都在讨论说去使用这些 GPU。可是老实讲 ，GPU 实际上只有在少数的新创，就是 AI native 的这个公司在使用，因为它实在是太痛苦了。它 GPU is 比较 unstable， 所以你需要有 infra 人才、research 人才、预训练人才、后训练人才，还有 inference 的人才，才能去使用这些 GPU。那事实上现在也有一个范式的转移，就像是 Jensen 说的这个token factory 的一个概念，就是说我把这些 GPU 给虚拟化，变成这个模型服务，对吧？那我们就会集成上百种的模型，从语音模型 voice model， 再到可能是 video model， 这个还有以及 image model， 还有以及语言的大语言模型 for 不同的 context。那这样子的话，事实上可以让任何的企业快速的去使用 AI instead of 就是直接去使用去 provision 这些 GPU， 因为实在是非常非常困难。这不只是台湾的问题，而是全世界都是这样子。所以这能快速的去就像是教授刚刚说的，是去问这个问题，而不是说我就算已经知道该怎么问这个问题，却执行不了，这是非常痛苦的事情。所以是希望是说，把所有的这些困难点简化，变成一个 token 的模式，让大家去使用。我觉得这个可以 bridge， 就是说现在企业想要落地的一些困难，所以他们唯一需要思考的事情就是说 ，What should I do with AI？ 只要他去思考出来之后，他就能去快速的去执行，通过tokens 或是通过模型的服务 ，instead of 用 GPU。
哦，那讲到这个Token Factory 哦，那我还是要回到 Neil 这边哦，就是说这个 Vision Bay 即将启用全台湾最大，而且是全世界第一个用 NVIDIA GB300的一个超算中心了。我想这不是只是单纯盖一个 data center 而已，而是帮台湾打造在 AI 时代的一个基础的建设哈。就是我想请教你，就是说台湾过去很多企业甚至公部门 data 都得送到境外去做一些算力的处理，再传回来。那这跟我们一直强调的，或者说你也一直谈到这件事情，就是 key 的这些 data 跟这个 domain know-how 要怎么样留在台湾，这也就是大家一直提的这个主权 AI 的这个概念哈。那在台湾成为了一个这个 Neo Cloud， 要怎么样平衡你跟传统的这些大型的 CSP 的关系？那在一个同时又竞争又合作的情况之下，你要怎么找到那个平衡点呢？
好，谢谢主持人。我想这个问题我常常被问啊，尤其这个我来自于这个鸿海集团，那我们很多的客户也都是 CSP 这些这个客户。那坦白说，这1年多前，当我们宣布说我们要 这个踏入这个 AIDC 的这个产业的时候，很多的客户确实对于我们有蛮大的 concern。那1年过后的今天，其实我发现的 chemistry 已经在改变了。那它改变有几个原因呢？第一个是 GPU 短缺，所以呢，造成这个 CSP， 我们看到美国很多的这个 CSP 业者，它跟这些 Neo Cloud 的 Service Provider 在这个合作，所以其实已经逐步的不是一个这个竞争关系，而是一个这个合作关系。那第二个呢是这个 CAPEX 转 OPEX， 我想前阵子这个华尔街其实对这一块非常有疑虑，所以造成了这个股价有一段时间其实不是那么的这个亮眼，某种程度跟 CAPEX 转 OPEX 的关系。那刚好我们接到了这样的一个这个生意机会。那第三个呢，我觉得是这个产业它还处在一个分工被定义的一个状态。我为什么这么说呢？我们看这个 PC 跟这个手机 industry， 其实在最早之前，我们这些 OEM 的客户都有自己的工厂，所以他一方面他要经营这个品牌，一方面要做工厂。但是人不是万能，所以最后的结果就是走向分工，大家去负责这个最擅长的那个专业，所以 OEM 逐步的把工厂的包袱丢掉，丢给 ODM 或 EMS 去处理。那 OEM 专心在产品的研发，在这个品牌的这个 marketing 上面。那我认为接下来的这个市场其实也会逐步的走向这样的一个模式，也就是说，我们的这些模型公司，或者是这些云端的服务业者，他就 focus 在他的这个云端的应用的服务的研发，甚至模型的研发，剩下的这个所需要的这些 token 或者算力，他交给这个愿意而且擅长建 AIDC 的这一票人去做处理就好。所以这样的一个分工，它会让整个的这个创新的研发的速度，其实会走得更快。
是，
那你现在看到你的这些新创的客人，在开创新的应用的时候，你看到你有看到明确的一个方向吗？因为我们现在看到的就是可能有少数1、2个有爆发出来，可是没有看到一个明显的趋势。我们知道 Agentic AI 要起来，我们知道 Physical AI 要起来，我们看到1、2间少数的公司起来。那你从你的角度来看，因为你有一些现成的客人，你有看到面向比我们广的情况，你有看到一个比较大的趋势吗？就是说这个有没有哪几个应用会先出来，还哪几个应用可能是第2波，哪几个应用可能是第3波呢？
其实这是一个很好的问题啦。那我认为所有的这个企业甚至模型公司都还在一个探索的阶段。那我们从这个应用端来看的话，其实是这个CSP 甚至模型公司，他知道他要做什么，但是在这个整个的企业面，因为企业面是最接近这个应用端的部分，我相信全世界现在很多的企业都还在 figure out 它的 application 到底是什么？它如何把这个 AI 的 agent， 把它这个 apply 到它的这个 workflow 上面？所以我觉得这是一个非常有潜力的一个机会。为什么 AI 现在这么多的潜力在那边？就是因为很多的应用还没有被开发，包括 Fastcom 自己。我们内部我们有这个 Smart Manufacturing、Smart City， 其实我们也都在针对每一个 industry 的这个应用去做这个发想，去做这个 figure out。那因为我们有场景，所以我们比较好知道说，原来我在 manufacturing 的部分，我有哪些应用其实是可以被定义出来。那这也是为什么很多的这个模型公司，我们现在看到这个 OpenAI 或甚至这个 Anthropic 并购了一些顾问服务公司，因为他知道。他必须要走进这个企业，去针对每一个不同的 segment， 不论是 semiconductor、医疗、国防安全等等的每一个 single segment 去做这个 deep dive， 他才能更清楚的知道说哪些产品是应该被这个开发出来。那我认为，我们身处台湾，其实在很多的领域都是佼佼者，都是领先的地位，包括半导体，包括制造。 甚至医疗的部分。但过去台湾 focus 在这个传统硬体的这个领域，过去也没有一个像我们要盖在台湾落地的一个 AI data center， 把资料放在这个自己的这个local 端的。那我相信台湾本来就有一个很强的这个 domain knowledge， 甚至很多的这个 data 储存在 local， 只是说要有一个这个 advanced 的一个 computing 的这个 capability 去帮它把它 enable， 然后让整个的这个 domain 因为有好的算力，所以它能做更有价值的一个事情。
所以我想很快请教3位各一个问题哦，就是你们可以分享，就在台湾，如果说从这个你们新创公司跟学校，也许跟政府是怎么样来一起来合作，就整个生态系统要怎么合作，去培养人才，或是建立这个主权在台湾的数据中心的能力，因为它不是只是算力的问题，它还包含所有的这个业务模式的这种创新啊，或者是人才的培养啊，或者是这个就是公司跟学校之间的一个合作啊，尤其是在创新啊，或者是怎么样子，您可以稍微每一位都稍微分享。
好啊，我可以讲一下吧，就是现在事实上也有一个范式的转移吧，就是从 training 转到 inferencing。那我可以补充一下这个刚刚的一些问题 ，if I may， 就是现在有2个点在 inferencing 已经是显知，就大家每个人都知道 ，scaling 非常快。那简单来说，有一个 common denominator， 就是说 AI 是非常非常好在解决 structure problem set， 所以像是有一个 single source of truth， 像是 coding 这个东西是已经基本上是大家都在使用。那你也看到 Anthropic 增长非常快。那另外一个就是在 video 还有以及 image 模型成长非常快，所以这是2个赛道，就是已经是起飞了，就是 token 啊，还有是使用量啊都增加。那这个相应的就是说 ，OK， 既然这2个产业已经增加了，那 as a 云公司我们就是服务这些东西，服务这些人嘛，所以有几个人才会需要大量的增加。那我觉得是台湾是非常可以专注培养，尤其是台湾是硬件的王国，那硬件上面的这些 firmware 都非常强势，所以可能是在机房的建设的这个 DevOps，K8S 的管理人才 ，Bare Metal 的管理，就是集群的管理这些的人才非常缺，还有甚至是说去做 networking， 就是光传说，因为你要做整个集群的规模化，都需要做这个。非常大量的这个 networking 的人才都非常需要，这是底层。那中层的话，就是说现在说token maxing， 不知道你听过这个东西啊？有一家公司什么1个月花了5亿美金，那这个东西实在是太夸张了。美国不是每家美国企业都可以这样子玩的，所以事实上就是做这个 optimization， 就是做优化，要么就是降本，要么就是提速，对吧？那这些东西都是服务于不同的模型。从就是 video、image、audio， 还有以及语言模型、不同文本的长度的 reasoning 的模型、non-reasoner 模型，都需要做优化。那这些做优化的人才，我觉得像是台大啊这些东西是非常非常可以去专注在 focus 上面。这个人才在全世界非常非常非常的缺。那在上层就是说what questions to ask， 那就是说这些东西都可以让我们这些云。基础资源可以 figure out， 我们可以把它解决掉，对吧？我们就 focus 在我们做完帮你执行。可是现在就是说，我如何把东西都在一起？所以我们可能会需要新世代的这些人，在大学的或是即将毕业的人，这些 AI native 的人去思考说 what application to build。所以我们会希望是说，既然这么简单可以去做这些AI native 的软件，那就是说一个就是专门做就叫 I call it product genius。对吧？你可以把东西都在一起就好了。那怎么执行我们来弄？那你就要去 focus on 怎么去都成一个 application 吧。所以主要是分3层，就是在 application， 再到 inference 优化，再到底层的建机房的种种需要的所有人才，我觉得都是台湾是可以去现在缺的这些部分。
谢谢。那林教授，
好，我可以举一些近期实际的，我们跟业界其实跟 NVIDIA 合作的案例，说明说学校跟业界怎么样合作可以得到双赢。那其实学界很多时候我们空有想法，但是我们算力非常的短缺，所以我们的资源非常有限。大家其实有时候很难想象啊，学界的资源到底是有 多么的拮据。我看网络上有人在讨论说，李宏毅实验室到底应该有几张 H100？ 不要说 H100， 我们一张 A100 都没有啊，我们什么运算资源都没有。
这下大家都听到了。
哎，大家都听到，好，这个答案现在有了。好，所以呢，但是我们就跟 NVIDIA 合作，然后呢 ，NVIDIA 借了我们这个是用 Taipei One 的算力，有16张 H100。然后呢，我们就帮台大训练，我们实验室帮台大的这个 NTU Core， 在台大大力的支持之下，训练了一个我们台大自己的语音辨识系统。所以以后呢，我们的课程只要上传到我们的课程平台叫 NTU Core， 就会自动产生字幕。那你可能觉得产生字幕也没有什么稀奇，但是我们的课程往往是中英交杂或很多专有名词，所以我们拿所有现成的商用系统，包括 OpenAI 的 Whisper，都没有办法得到很好的辨识率，但是我们针对我们自己的课程呢，训练语音辨识系统可以做得比 OpenAI 还要好，而且我们的速度，因为我们模型比较小，所以速度呢是 OpenAI 最好的模型的5倍。那这个就带来了很大的好处，这个就是一个合作的双赢。还有另外一个例子呢，这也是跟 NVIDIA 合作。那在那个 project 里面 ，NVIDIA 也提供了运算资源，然后我们去训练一个语言模型。所以语音语言模型就是它可以输入声音，然后它不只做语音辨识，它还要听懂所有的东西，知道这个人的性别，知道这个人的情绪，知道所有的事情，然后给一个合适的回应。那这是今天非常热门的题目。那我们有一个好的算法，但是我们没有运算资源来训练这个模型，所以我们跟 NVIDIA 合作，那用5000小时的资料来训练一个叫做，我们把那个模型命名为 Delta 啊，叫做 Delta 的模型。虽然你觉得5000小时没有很多，但那是我们在那个算力下可以用到的最大的资料量。那但是平常我们也训练不了那么多模型。那个模型呢，是比当时阿里巴巴开源的千问 2结果还要更好的，而千问2用的这个资料量呢是我们的100倍，但是我们算法比较好，所以可以在有限的算力之下得到更好的结果，所以这个就是业界跟学界合作的双赢。
其实这个逆境中才会有成长，所以就是因为算力不够，逼着你们在逆境中突破，就很少的算力也会有很大的一个模型的进展。
就是我们算力有限的时候，我们必须要想好的方法。
对，那Neil
是我人才确实是我们现在面临最大的问题之一啊。那我分2块，一块是我们内部的 operation。坦白讲，我们现在找人确实是很困难。那尤其因为我们第一次，也是台湾第一个在台湾要建立这么大的规模的集群，包括很多的机电啊、空调啊，甚至 cloud operation 的人，其实方方面面我们都缺。那台湾过去没有这么大集群的这种人才库在这边，所以某种程度我们现在也找了很多这种相关的这个背景的人。你只要有相关背景，你愿意学的，那我就提供这个平台给你来做这个学习，然后赶紧的这个 hands on。同一个时间，我们也跟一些学校开始在谈合作。你应届毕业之前，你毕业之前呢，我给你来 intern， 那你毕业之后可能就可以 on board。另外一块。这是比较偏这个供应链端的，另外一块是这个 AI 应用端。这一块其实我们跟政府也有一些这个合作，也一直在想说，如何通过，因为我们已经有了一个先进算力，通过先进算力让政府去做这个 LK， 然后它 LK 给到一些新创或者学术的这个机构，所以去这个incubate 这些 AI 的应用人才。
Tracy， 你觉不觉得我们今天就是这个好像是一个 Team Taiwan 的延伸？是。我们有最资深的前辈，有中生代，还有一些新血。我想这个 Team Taiwan
充满希望。
充满希望。Taiwan can help AI industry。我想这应该是今天最好的一个总结。
而且我想今天的在座的不仅是那种业界的大佬，新兴学子，应该都听到3位各位应该有很多的想法，然后希望能够投入这个未来的个重要的个AI 时刻来。好，那么再过几分钟 ，Jason 就会在隔壁会场登台演讲，他将与各位分享 NVIDIA 的愿景，以及如何建构我们刚才所讨论的未来。
我们要谢谢今天结束的嘉宾，谢谢他们分享 AI 的未来的发展以及所带来的洞见与愿景，同时也感谢 NVIDIA 全体同仁以及我的搭档 Tracy。
也谢谢 Bruce， 谢谢 NVIDIA， 让这群各领域的杰出领袖今天都能够齐聚一堂在台北。
Jensen 马上就要上台发表主题演讲了，我想你们跟我一样都等不及了。感谢世界各地所有正在收看的观众朋友，谢谢大家。
我是在台北流行音乐中心现场的 Tracy 蔡。
我是 Bruce Lu， 谢谢大家的收看，欢迎参加 GTC 大会。
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge, reason, action. They reveal patterns in complexity you could never see. Mirror our cities to keep us safe. And lift us high above them. Tokens help robots learn from us. They go where we cannot. Lending us helping hands. And closing the gap between hope and healing so that we breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground on a scale never attempted. So we can reach Star Cloud 1 separation confirmed to infinity and beyond. Together, we take the next great leap into a bright new future built and beyond. Together, we take the next great leap into a bright new future built for all mankind. And here in Taipei is where it all begins.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad. And a round of applause for our pre-game show superstars, ladies and gentlemen. Look how adorable they are. The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan. 70 different conferences are going at the same time. Everybody is watching this keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here. I mean, there are so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. Inside, this is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model, or many, sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrates this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codex does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to NVIDIA I logo, then scatter and repeat, right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool. Create a CAD file, ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said, you know, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough, and in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA-X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA-X libraries. Let's take a look.
20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. CUDA-X libraries are tools for agents. cuLitho for computational lithography. cuOpt for decision optimization. cuDSS for direct sparse solvers. AIQ for deep research across structured and unstructured documents. Ariel for AI RAN. Warp for differentiable physics. Parabricks for genomics. At their foundation are algorithms, and they are beautiful.
A round of applause for math. Math is beautiful. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales. And each one of those steps are running in a different part of the computer. And you could see the large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with the large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated users of tools, which is the reason why the CUDA-X libraries that I showed you are going to be incredibly popular with agents. They solve some of the most important problems the world knows. And all of our CUDA-X libraries are now going to come with skills that the AI could learn how to use. So the CUDA-X library, some skills, basically a manual. The AI reads it and go, aha, that's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called a DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you could see, every aspect of this computing model, this computing pattern, this new application called an agent, is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason this disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation, Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with the GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin, from end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called Doka. The security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers. Not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle. And it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company. But over the years, we've evolved to become a systems company. You're looking here now for the most complex system, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex, every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end, because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout, simulate the power and cooling, design the network, validate every integration, test every change in the digital twin. The factory powers on. DSX OS takes over and provisions, operates, monitors, and remediates the infrastructure, turning the installed systems into trusted, multi-tenant, resilient, AI-ready capacity. Today's AI factories over-provision power by up to 40%. DSX Max LPS lets operators safely deploy more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts, sending them where work is happening. In-rack power smoothing flattens peak current spikes and power surges. Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance cooling and power to meet workload demand. DSX AI factories are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
I've shown you ecosystem slides of the past where NVIDIA's computing layers and software and computing stacks are integrated into other people's platforms, third-party platforms and libraries that serves end markets. That was a computing ecosystem. This is an AI factory ecosystem. This is way downstream of all of you. Upstream of me is all of you, and downstream of us is this ecosystem. Because NVIDIA ultimately is not just building a GPU, not just building a system, we're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $20, $30 billion. It is at $50, $60 billion, and soon it will be $80, $100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, we used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true. So that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem, we call it DSX. RTX is for our GPU, DGX is for our systems, and now DSX, basically infrastructure. Because of the work that we do here, across this entire stack, including our systems and software, it's the reason why we can work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth $50, $60, $70 billion and growing incredibly fast. Recently, we worked with Nebius, and again, they're growing incredibly fast. Each one of these clouds have incredible customers. Cursor, the software coding company, Black Mountain Labs, Image Generation, World Labs, World Foundation Model, Revolut, the leading financial services AI company, and Shopify. Here's another one. This is Nscale, and their customers are British Telecom, Google. Google is using one of our AI clouds, Thinking Machines, a Frontier Labs company, super exciting. Here's Naver Cloud in Korea, Bank of Korea, Hyundai, so many incredible companies. Here's one in India, Yoda, incredible companies. Here's one based in Singapore, building in Australia, Together AI, AI Singapore. This is one in Indonesia. Each one of these companies are serving regional as well as global customers. AI is going to run everywhere. Every company will be powered by it. Every region will build it. Indosat here in Indonesia. Here in Taiwan, GMI. Here in Taiwan, GMI. It's okay to clap. So, incredible companies, incredible opportunity, but all of them need several things. Of course, they need the computing stack. This entire stack underneath, this is what made NVIDIA famous. All of our hardware and software and libraries, our connection into the world's ecosystem of third-party developers makes it possible for anyone to stand up an AI cloud. However, the AI cloud is so complex now. This is the software version. This is the computer science version. The money version, the asset version is what I showed you earlier. It's a giant factory. Having this ability alone is not enough, which is the reason why NVIDIA has become an AI infrastructure company. Now, doing this well and becoming incredibly good at helping customers build AI factories and deploying AI factories is incredibly important. And the reason for that is this: compute is revenue now. Compute is profit. the absence of revenues and profit is loss. And so it's really important to realize that this is an example of an AI infrastructure coming online. It could be coming online quickly, it could take a while. Its throughput could be high, it could be low. Its resilience and reliability could be good or bad. And its lifetime of usefulness could be long or short. Because this represents 50, 60, going to $100 billion. This curve matters greatly, which is the reason why NVIDIA is such a great partner. Working with us because of our fully integrated capability, we didn't just come up with a PowerPoint slide. We created the entire infrastructure. We connected everything together. We built out billions and billions of it ourselves to make sure that everything works well. As a result of that, our time to first token, our time to first inference, our time to training turned on is much faster. Second, because our throughput per watt, our tokens per watt, is utterly world-class. And the reason for that is because we integrate everything, we design everything from the ground up, we simulate the entire system, and we use extreme co-design. Just like I showed you just now with the Vera Rubin rack, everything was designed in order to deliver on this incredible throughput. If your data center, if your factory has 1 gigawatt, it will not have more. 1 gigawatt means 1 gigawatt. That's all the power generation you could do. If you have 1 gigawatt of power, then throughput per watt is revenues, because every token is profitable. Every token is revenues. This is the future. Compute is revenues. Performance per watt is your revenues. Choosing the wrong architecture just because the chips are cheaper doesn't translate, doesn't make sense. You need to make sure that your revenues per watt, the more you buy, the more you make. And so tokens per watt. And then lastly, third is reliability. If you ever get a chance to see these data centers, there are so many moving parts, millions of cables. The ability for all of those computers to work harmoniously, reliably, is extremely low. It is just extremely difficult. We have now been operating very large scale for a very long time. That experience matters. That difference, mean time between interrupts, extremely important. And then lastly, this is very hard. The lifetime of these systems, the software is changing all the time. 4 years ago, which is in the time of Hopper, AI has completely changed. 6 years ago, this is the time frame of Ampere, AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers, and then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make. Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard. Your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super, super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production. Vera Rubin is in full production. The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster, and we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you. Let's take a look.
Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod-scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX-1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape through hundreds of processing steps. 3-nanometer process, CoWoS-R and CoWoS-L packaging, HBM4 memory from Micron, SK Hynix, and Samsung. The Vera Rubin compute board. 6 trillion transistors with over 18,000 components on one board. Vera Rubin NVL72 does the thinking, prompt and context understanding, reasoning, and planning. Next, a new modular compute tray, streamlined with a new PCB mid-plane design, super chips, Connect X9 Super NICs, and Bluefield 4 DPUs, all made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency manifolds, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin NVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin NVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPX takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While NVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera Bluefield 4 STX, where AI keeps its memory. Storage processing accelerated by Bluefield 4, connecting memory, storage, and in-silicon security and NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUPE process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents, 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today, as we bring Vera Rubin to the world. Thank you, Taiwan.
Ladies and gentlemen, Vera Rubin. Vera Rubin was not just built for AI. Vera Rubin was not built just to run AI. Vera Rubin was built to run agents. This is an agentic system. Imagine the complexity, which is the reason why agents is the last computer science breakthrough. It has taken this many years for agents to realize its potential and become useful. It stands to reason that the computer that runs it is the most advanced in the world. This is Vera Rubin. Let's take a look. Can we bring out Vera Rubin, please? And Janine, do we have the racks, the systems? It looks heavy. This is Vera Rubin. Vera Rubin NVLink 72. This is the Grok LPX. At the next GTC, I'm going to talk to you about a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology all coming together. Now, when we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we were working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, you know, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy. We could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 72. Today, NVIDIA's token cost is the lowest in the world, not by 10%, by X factors, orders of magnitude, all because we did extreme co-design, all because we understood the computing model, the computing pattern of inference, and we were able to create NVLink 72. Now, with Vera Rubin, it is beyond inference. It is now inference in an agentic system. This is Vera Rubin. No cables, no hoses, no fans. What used to take the last time when I showed this to you, we had cables everywhere. The cables were amazing to look at. But now, there's a PCB in the middle, which connects both sides. What used to take 2 hours now takes 5 minutes. The reliability and the resilience of Vera Rubin is going to be off the charts. This is our Vera CPU tray, the most advanced CPUs that has ever been built. I'm going to show you that in just a second. And this is our storage tray. 2 Vera CPUs, 4 CX9, incredible amounts of software. This is our new LPX, LPU30, the Grok system, designed for very low latency inference. The throughput is delivered by Vera Rubin and extended with NVLink 72. If you want to extend that even further, you can have Grok LPUs. Here, we have the Vera Rubin NVLink, the switch tray. This is the switches in the middle, and this is revolutionary. Because of Vera Rubin's, because of NVLink 72 and the NVLink switches that we created and invented. And this is our Ethernet switches for scale out. What's amazing is we introduced these 2 systems for Grace Blackwell. These 2 systems were created for Grace Blackwell. And today, NVIDIA is the largest networking company in the world. I'm so proud of the networking team. This is such an incredible enabler for everything that we do. I'm going to now talk to you about the next major industry we're going to be part of. Thank you. Janine? Thank you. I think there are 2,000 people back there pulling that. Okay, let's talk about CPUs. Vera CPUs. CPUs built for the age of AI. All of the CPUs until now were created for people. We were the users. We were the users. We were the renters. The way we use CPUs, we live in a world counted by seconds. The way we rent CPUs in the cloud, each one of them, more CPU cores you have, the more you can rent. The economics of the use case of the old CPU and the economics of the old CPU, fundamentally different than agents. Agents are impatient. They don't live in a world that is in seconds. They live in a world that's in nanoseconds. When it uses a tool, it wants the response time to be as fast as possible. When it accesses database, it has to come back as soon as possible. Every moment that the agent is waiting keeps it from going to the next step, the next step, the next step. It is vital that we make the CPUs as low latency as possible, as interactive as possible. So we created Vera CPU for the age of AI. Now, inside our system, it's used for 3 different ways. The first way, of course, is Vera Rubin for thinking. And inside the Vera Rubin rack, there are already 2 CPUs. As you know, we are building and selling millions of Vera Rubins. We have sold millions of Grace Blackwells. NVIDIA already is one of the largest CPU makers in the world. In the Vera Rubin rack are 2 CPUs. One for orchestrating and managing the GPUs, managing the KV cache, dealing with all of the software that runs in the rack. We also have the Grace Bluefield that is used for security and isolation. The Vera Compute is used for the harness, the orchestration of the AI models, tool use, accessing the database. And the data servers are right here, Vera Bluefield, the fastest storage servers, the fastest storage system the world has ever made. And the reason why this is so vital is because agents are accessing memory so incredibly fast. These systems, the storage server and the CPUs, are now the critical path of the most expensive part of the data center. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up. A CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past, we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind. The 4 takeaways. The first takeaway is that the instructions per clock of Vera has to be incredibly good because we need the latency to be short. We need the processing time, single-threaded performance. Not throughput, single-threaded performance has to be world-class, absolutely the best. Single-threaded performance, which is the reason why the IPC, the instructions per clock of Vera, is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number 1. Number 2, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world-class. This is the first CPU that's been built a long time that is literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light, 3.6 terabytes per second. No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core, they're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded performance, real performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? Let's take a look.
Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU built for the agentic loop, combining NVIDIA's custom data center CPU core with the scalable coherency fabric for the right balance of performance cores and bandwidth to maximize AI factory output. At the heart of Vera is the NVIDIA Olympus core, built for modern data center workloads, branch-heavy Python runtimes, tool calls, and sandbox code execution. Each core is tuned for throughput, a neural branch predictor evaluating 2 taken branches per cycle. A 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data path. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory, while correcting multiple errors simultaneously without compromising bandwidth. Vera achieves 40% lower peak memory latency versus x86, keeping cores fed on time through retrieval, analytics, and sandbox execution. NVIDIA's second-generation scalable coherency fabric unifies all 88 Olympus cores on a monolithic mesh with separate dies for memory and I/O. Cores are not split across chiplets, enabling 50% faster core-to-core communication than traditional CPUs. And memory-coherent NVLink chip-to-chip connects GPUs directly to the fabric. Beyond GPUs, NVLink chip-to-chip can scale Vera up to multiple sockets, enabling massive bandwidth between CPUs. Vera delivers 1.8 times the agentic sandbox performance of x86 CPUs. Standalone Vera racks run agent sandboxes, tools, code, and data pipelines. Tightly coupled to Rubin GPUs, Vera keeps accelerated workflows moving. NVIDIA Vera Bluefield 4 STX powers context memory and AI storage. Compute, networking, storage. Vera is the CPU for the age of agents.
This is going to be our new major growth driver. The reviews are already coming out, and it's pretty good. That's pretty good stuff. Now remember, Grace and Vera are also the most highly qualified CPUs in the world of AI, because every single data center, every single cloud, every single enterprise, every company that works with NVIDIA on AI has already qualified Grace. The entire software stack has already been optimized for Grace. Every company will be qualifying Vera. Vera will be the most optimized agentic CPU in the world, simply because it's going to go with Vera Rubin. Simply because we made the big hard switch. In fact, during Grace Blackwell transition, the biggest risk was going from external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell. When people say Blackwell, they say Grace Blackwell, because it is utterly now everywhere. Every company's software stack has been optimized for it. Everybody's security stack has been optimized for it. And now here comes Vera. I'm super excited about that. Now look at some of the performance numbers. Speedups is one thing. It is extremely hard to speed up SQL. SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster. Not 10% faster, not 25% faster, 10 times, 3 times faster. Incredible. This is real-time. The next one is real-time stream processing. Remember, your AI is going to be not just reading documents. Your AI is going to be watching for telemetry, especially inside a factory, inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single threaded instruction execution, the bandwidth inside between the cores, the bandwidth outside. Vera is completely revolutionary. That's Vera. X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPUs. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up. It's opened up a brand new market. Agents is a new workload. We built CPUs for humans in the past. We need CPUs for agents, agentic systems. The properties are different. Why would the old CPUs be the same? We are building millions and millions of errors. And to go to market with us, Taiwan's ODMs and computer makers, all the OEMs, and you could see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market. CPU for agents. And this market will surely be larger than the last. And the reason for that is because there'll be a lot more agents than there are people, and then the agents are very impatient. So, NVIDIA, Vera CPU. Thank you. This is the most important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it. Every company will be an agent company. Every company will have agents running inside. Every company will see that agents will need its own operating system. Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the NVIDIA Agent Toolkit for Enterprise AI. You've seen me build this in plain sight. Almost everything that NVIDIA does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today. This you've seen me talking about for several years now because we've been building for this moment. There are 4 things that companies need in order to build agents as a service or build agents to operate. The first thing you need is you need models. Of course, large language models. The smarter, the better. The cheaper, the better. The faster, the better. The second is you need a harness to orchestrate the whole thing. The third, these models want to use tools. And these tools come with its skills. And I showed you CUDA-X libraries. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA toolkit for agents. It includes models that you can modify, NVIDIA's world-class open models, and I'm going to show you more. You can run agents from anybody. You could run Cloud Code, incredible agent, Codex, incredible agent. You could run it inside this harness called OpenShell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. Its identity is protected. And so this OpenShell is being adopted all over the world. NVIDIA OpenShell is open source. You're going to see so many companies adopt it. Red Hat, Canonical, Microsoft. It's going to be adopted everywhere. This is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere, okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents is chip designers. It is the single most important thing that NVIDIA does. And so, of course, we have to partner with Cadence to build super agent, a chip design super agent. It is orchestrated by Codex or Cloud Code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents. And let's take a look. It's really incredible.
Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI models. Designing these chips and the systems they run in is one of the hardest engineering challenges. Trillions of transistors, 3-dimensional circuits, microscopic scale. Every gate, every wire, synchronized to picoseconds, must work in perfect harmony, with no margin for error. Physical prototypes are too slow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At NVIDIA, thousands of engineers, billions of compute hours per year, millions of tests, written, run, and debugged. A cycle that takes teams weeks. To compress this cycle, Cadence and NVIDIA built a design verification agent. Codex orchestrates the process. Cadence ChipStack launches the RTL verification loop, powered by Nematron and secured by NVIDIA OpenShell. Calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The ChipStack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper. Design flaws revealed, bugs in the code fixed. What once took weeks now takes hours. Verification cycles over 40 times faster. Together, NVIDIA and Cadence are reinventing chip design with AI agents.
From weeks to hours. From weeks to hours. NVIDIA has thousands of chip designers. We are going to hire hundreds of thousands of Cadence super agents that work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence with their proprietary knowledge. They have to start with an excellent model. We call it Nemotron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today, we're announcing the Nemotron 3 Ultra. Yep, our next open model. And it is smart. The Nemotron models not only give you the model, we give you all the data that we use to train the model. And because we have a coalition of incredible partners, you can see all of our partners down here, we work together, contribute data to each other. Nemotron is trained on one of the largest suites of long-running reasoning models, long-running tool, task-solving, tool-using data sets in the world because of all of our great partnerships. All of this from the model, the training script, and the data made completely available to you. This is open models at its best. The best open model system policies in the world. Simple goal is so that you can take all of it, add to it, make it even better, make it yours. Nemotron 3 Ultra is 5 times faster. This is the world's first model based on a hybrid architecture of SSM, state space models, with mixture of experts. The architecture is incredibly fast. We made it fast so that you could think fast. When you think fast, you could think longer at the same cost. So 5 times faster. It is also 30% cheaper, 30% lower cost to run in total flops and total inference time than even the most cost-effective in the world. We're comparing against the world's best open models. Frontier Smart, 5 times faster, 30% cheaper, completely open. We're completely dedicated to this. This is now Nemotron 3. We're currently working on Nemotron 4. So this entire toolkit, from models, harnesses, tools and skills, and runtimes, is the reason why every enterprise company in the world has the ability now to create their own agents, just like Cadence did with their super agents. And we're working with so many companies, Cadence and CrowdStrike and Dassault and Palantir, SAP and ServiceNow. People were always said, Jensen, the agents are going to disrupt these markets. I said completely opposite, and you can now see it. Agents is going to create the largest opportunity ever for my partners and friends. And we have the NVIDIA Agentic Toolkit for enterprise AI to help them. So, there you go. First, Vera Rubin in full production. 2, Vera CPU, CPU built for a new generation for agents. And 3, NVIDIA's enterprise AI toolkits so that every enterprise and every enterprise software company can build agents. My relationship with you started here. And many of my friends and partners here in Taiwan, your companies started here. This is, in a lot of ways, the beginning of the modern computer industry, 40 years now. NVIDIA is 33 years old. The PC industry was already starting to get to Windows 1 and Windows 2 and Apple 1 and Apple 2. And by the time that we came along, Windows 3.1 was the PC. And as you know, Windows 95 made PC personal. It took PC from enterprises, companies, and made it into a consumer electronics device. Everybody should have one, and everybody does. This is the beginning. This computing platform did several things incredibly smart. Windows was not just disaggregated, as you know. Windows was properly abstracted. It was architected just right. Systems BIOSes, open chipsets, the operating system with drivers that could be connected and installed at runtime, and an abstraction layer with a multimedia API that opened up the PC to what we all know today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now, tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya, where we're going to talk a lot more about the work that we're doing together. Microsoft and NVIDIA, over the last 3 years, it took this long to completely reinvent how the PC is going to work so that we could be ready for this moment. As I mentioned earlier, that compute pattern called the agent is going to run in AI clouds. It's going to run inside enterprises. It is also going to run on your PC. What's going to happen to that PC when it has an autonomous agent? An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. Our personal AI, sandboxed for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark. Everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek. Fused by NVLink. 128 gigabytes of unified memory. TSMC 3 nanometer process. 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer. For creating. For gaming. For agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
Here it is. Of course, I got to show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him. Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now, thank you. I have too many things in my pocket. 太多东西了. Okay, all right. This is the most amazing chip the world has ever built. This is the N1X that we built in partnership with MediaTek. I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that, frankly, would take 33 years to build. And the reason for that is because 100% of NVIDIA software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. You want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created, and every single application that Windows has ever run. Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it. Okay, now I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Super model, or it could have Claude Code or Codex or some other model in the cloud or something on the network, and it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness connected to Claude Sonnet in the cloud. I select the site, share my concept sketches and mood board of styles to inspire my design, and the prompt, a text description of the requirements and the design intent. My agent goes to work. Using the tools on my laptop, it opens Rhino and starts modeling the site, shaping terrain, setbacks, and the building envelope. Then it proposes building forms, optimized for cost, comfort, and quality. With the form defined, my agent generates the interior layout. Walls, circulation, rooms begin to take shape. I jump in whenever I want, to adjust, to change. Doors, windows, and structural elements are placed automatically. My agent detects its own mistakes and fixes them. When I approve, the agent exports the model from Rhino into Blender. Materials and object properties transfer with the design context intact. I fine-tune the materials, get the look just right. Then, I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent. Working with me on RTX Spark. Design at the speed of imagination.
PC in the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they'll release it for RTX Spark. It is twice as fast. It's already fast. Now it's going to be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically everybody. Everybody will support RTX Spark and will be building incredibly smart and powerful and beautiful laptops with all of us. Thank you very much. But that's not all. That's not all. RTX Spark is a reinvention of laptop. But in fact, Microsoft and NVIDIA is reinventing all of PC. And today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that runs, that you see that runs on NVIDIA in all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now, what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours. Okay, look how beautiful it is. This agent could run 24/7, meter-free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's sitting here connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this, and this becomes your personal AI, your personal AI agent. And it gets smarter and smarter and smarter over time, because today we have Nemotron 3 Ultra, tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I am certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool, whether you launch applications, click and type, and this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, where many houses have home theaters, big TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And it's running all of your agents, it's running all of your assistants. And they're doing all kinds of things for you all the time. And you have to have it in your house, just like you have a home theater in your house, you have stereos in your house, you have game consoles in your house. You would have AI agent computers running in your house. And these, in time, becomes a lot more like R2-D2 to you. It becomes more like C3PO to you than it feels like a PC to you. There is no question this reinvention of the computer is as big of a deal as the reinvention of the phone into what we now know as the smartphone. And so this is the beginning of that journey. This is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I'm just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. A new line, a new beginning. Thank you. As you know, agentic AI is just a digital robot. It understands, it reasons, it plans, and it acts and uses tools. Agentic AI is going to run across all of these computers. And you've seen me talk about each and every one of these over time. We're working on humanoid robotics computers of all kinds. We're working on self-driving car computers. We're working on satellites. You have GeForce, which has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we trained on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perception, the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning, human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning, verifiable rewards, okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person, and now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we are announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There are so many people working on it. However, in physical AI, we are absolutely the world's best. I am so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3, that can understand and reason. It can generate. It can simulate in the loop. It can even be the policy itself. It is on the top of leaderboards all over the world. I am incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni-model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future, frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher generated by compute. Cosmos, the foundation for developers of the age of physical AI.
It takes data plus compute, gives you AI. Now that we have AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open the model, we open the data, and we even open how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI, agentic robot that is an autonomous vehicle, has also this complicated stack. Today, we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime with the Halos operating system, we will be able to connect to all of these services across the world. Let's take a look at this.
Hey Mercedes, let's go to my favorite sandwich shop.
Routing to your destination. Lane is clear, pulling out to start drive. Nudge left due to the stationary lead vehicle ahead blocking our lane. Slow down to stop at the stop sign controlling the intersection. Stop to yield to the pedestrian since the person is in our lane. Yield to the cut-in vehicle from the left. Nudge left to clear the stopped vehicle blocking on the right. Keep distance to the cut-in vehicle since it is merging into our lane. Nudge left due to the stopped van blocking the right side of our lane. They are in our lane. Pedestrian crossing ahead. Stop to keep distance to the lead vehicle. Keep distance to the vehicle directly ahead in our lane. Keep distance to the vehicle directly ahead in our lane. Stop to the stop sign since the intersection is controlled by a stop sign. Stop to yield to the cross traffic since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge left due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Nudge left due to the truck blocking the right side of our lane. Your destination is on the right.
Alpha Mayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpha Mayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GR00T is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GR00T platform, the Isaac GR00T platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human or robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today we're announcing the NVIDIA Isaac GR00T, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot. 6 feet, 150 pounds. Just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac GR00T, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos, scaling one demonstration into thousands. Train policies. Evaluate them in Isaac Lab Arena. deployed through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. Groot is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac Groot Reference Design Robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, anywhere. The age of robotics starts here. NVIDIA Isaac Groot.
So many robots. We're working with just about everybody who's working on robots in the world, or robotic systems in the world. Let me tell you what I told you. The computer industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You'll use different models because of your preference. You will improve them for your proprietary use. You would create super agents that you can rent to other people to help them do their work. This agentic platform, this agentic pattern, NVIDIA has an enterprise AI toolkit. This is a wonderful way for all of you to engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is an entire disaggregated, distributed agent processing system. NVIDIA has really become an infrastructure company, not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic pattern agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs, but in the future, it'll be robots and satellites and base stations and factories in the cloud, on-prem, at the edge. This pattern, agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I am so proud of how you've been so successful this last year. The next year is going to be even more. I have one more thing for you. Let's take a look.
You ready, Taiwan? Let's do this.
The keynote's done at Computex. Jensen showed the world what's next. Useful AI has arrived. Agents working by your side. But in case you missed things We're gonna break it all down for you, Taipei.
Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms. But they need so much compute, we hear ya.
That's why we created Vera. Ruben score, the show is true. The cheapest tokens coming through.
10 times faster inference heaven. More special agents than 007.
Bluefield keeps agents' memory true.
Now let's talk about its CPU.
50% faster, that's outrageous.
Not for Vera.
It's built for agents. NVLink Fusion blends A6 smartly.
Everyone's welcome to the NVLink party.
Well, if you like that introduction,
Vera Rubin's in full production. Nemotron Ultra leads the run. 5x faster work gets done. Mimo Claw keeps the guardrails right. Open Shell keeps the sandbox tight.
your code migrated and reviewed.
All before this song is through.
AI is a 5-layer cake. Computes revenue, make no mistake.
Global AI clouds build lots of gigawatts. ESX keeps power lean, connecting dots.
Every watt optimized for you,
So you can have your cake.
can eat it too.
RTX Spark is finally here.
Biggest PC moment in
40 years. Agents powering all workflows. Running anywhere Windows go.
harnesses run on CPU.
Models fly on GPU.
Cosmos builds worlds that robots need.
Turning compute into synthetic feed.
Out from IOCs and reasons through.
Understands roads like people do.
Crude is how they learn to move.
Learning skills and finding grooves.
Unitrees powered by Thor.
The future's humanoid. Count on The future's bright. Come see what's next.
Thank you, Taiwan.
Welcome to Computex.
大家谢谢。Have a great Computex. 大家谢谢. Thanks for an amazing year. Thank you for all your friendship and support. Thank you. Take care. Have a great Computex.
Woke up feeling something shift. Same room, but the air felt thick. Mirror said I'm still that kid. Art said you're bigger than this. Tied my laces, hands still shook. First step was the hardest one. Every lap, every sideways look, all fade when the race is run. I carried every gap.
掌握分秒，累积财富。现在立即下载非凡新闻 APP，财经快很准，随时随地掌握先机。